Well, good morning, everybody, and welcome to today's talk. We made it to December now. It's getting cold out there. Actually, related to December, and the days getting shorter. This video will be about me prototyping specifically a light clamp for my bike. As I said, with the days coming shorter, at least here at the northern hemisphere. I now need to use a light in my bike, and I had some issues with it. The original clamp was not big enough for my handlebars, my current handlebars. So I'll be taking you guys through the steps on creating this particular object. I printed it out in both the Sketch and the MakerBot method 3D printers, so I have them. You can see them behind there. You've seen my setup before. I'm running both, the Sketch and the MakerBot Sketch and the MakerBot method over here at the studio. And having access to both of them, I actually, let me fade here. I actually prototyped this clamp in different, materials and different printers for separate reasons, right? So I actually have a sample handlebar over here. So we'll be talking about what, the general process for it was, also showing a little bit of the Rhino file that I used to design this part at, and yeah. Generally speaking, I think that it's going to be interesting for us to cover more of these sort of how-to tutorials. The goal here is not for you guys to know specifically how to make a bike clamp, right? But to think about how to approach any type of design problem, engineering problem that you might have at hand, and how to use either platform from MakerBot, that is. So that's either the Sketch, the method, the material selection, the actual prototyping process, all that jazz. So let's get started with what the issue was. And for that, I'm of course going to just show you guys the original product, right? So this is my my bike headlight, right? As you can see, it's just a single LED, rather powerful actually. And it comes with this clamp here that just, as you can imagine, this round area or circular area just clamps into your handlebar and allows you to have a light in the bike, particularly important now that the mornings are way darker than during the summer. So specifically, this one light, let me show you, clamps in and out of the shell like so, right? So I'll bring it closer to the camera here. Here we go. So it just slides into the clamp, and the clamp is made out of these two parts. Part one, well actually technically three if you take into consideration the actual set screw that comes in the clamp, right? Let me get it out. Here we go. Cleaning up the table a little bit. So part one, the light itself, I'm not going to be interacting with that. The goal here was I wanted to keep using the same light, right? But part two, the clamp itself, that's made of this, let's call it part A and part B, was a little bit too narrow for my new handlebars to fit in. I'll try to change the color balance in the video in just a second. But, generally speaking, these two parts, A and B, is part A would be the one that I wanted to redesign, right? This circle, that essentially is what clamps into the handlebar. And part B is just, the sliding element that allows the light, to actually slide into position once the clamp is in the bike, right? So this part I wasn't really too concerned about because, again, this is just an interfacing component. This one, however, is what was giving me the issues, right? As you can see, the circle is rather small. It's meant to be interfacing with a smaller radius of a handlebar, and I wanted to change that. So first off, just considering like the problem at hand, let me change. I'm being a little bit bothered by I don't know if you guys are too, but by the video settings here. Let me change that just a second. Here we go. Changing the saturation a little bit so it's not so bright. And 6, that should do it. All right, sorry about that. Just reconfiguring the video a little bit. This should be better for all of us to actually see what I'm talking about here. So the three parts, and finally I was saying, like, this is just a set screw that allows you to mount or to tighten up the mount into the handlebar, right? The issue here, many handlebars are will be like just this circular profile, which is fairly straightforward, and that's where the original clamp would, you know, really shine and work properly, right? It just slides into place. However, many more, say, road focused, that's road racing, focused handlebars in the bike will have different thicker profiles, right? So in the case of this particular one, you can see how the handlebar actually flares out from a circular profile into a thicker, you know, elongated profile. This is basically has to do with aerodynamics. We won't be getting too much into it, but the point is that it doesn't really follow the traditional pipe circular profile that you would expect in a more standard kind of city bike or urban bike, right? These are not the handlebars I was interfacing to, and I'll show you those in a second, but it shows the idea, right? My challenge here was that I was moving from a more straightforward profile that was following originally the circular, you know, the cylindrical element, into a more flared out or actually flattened out profile that had, you know, a bigger depth and shallower, shallower profile, but then elongated too. So it was no longer a cylinder. It was actually this sort of wing, sort of aerodynamic profile, right? So in any case, I'll just keep this to the side. So as you can see here, the main challenge is going to be to extend the size of the circle, right? Have this little leap of an element that actually receives the sliding, say the B part here, and also, of course, this cone that allows my main receiving part to nest inside, like so, right? So this is all there is, right? I needed to make the circle bigger while keeping the same elements or attachment points available for me to use, those being the cone here for the, you know, this guide, and the little leap here at the top of my part, for the part to actually be able to be secured in place. So let's start with that and jump into Rhino real quick. And if you have any questions, as usual, you know, Alejandra is keeping those tab of those in the back end. So feel free to comment those out in the comment section. I think it's to the right of the chat box in YouTube. But yeah, so here's my Rhino file, you know, kind of like where I started. As you can see, the main goal here is to sort of divide the problem at hand and simplify it as much as possible. So as I said before, we are talking essentially about a circle, you know, with a thickness, of course. So this would be the circle that actually receives the handlebar, the thickness of said circle, and then a little bit of an extension to actually have this cone. We are looking at a cross section of my part, right? As you can imagine here. So a thicker element here that will be receiving the cone, and finally that leap element that I mentioned before, right? So this is actually a fairly small detail that would be trickier to prototype, especially with you know, softer materials, but it was really important for me to actually so that I was able to keep this particular element attached properly and front facing towards the, you know, the front of the bike. So once I got the dimensions in, right, and as you can see, let me jump back here into my main table, right? So you can see here, the original design is not really quite a circle, right? It's got this kind of distorted circle profile, but again, as an approach, you know, like a kind of a close enough approximation, a circle would do. So I just essentially took my calipers, measure this guy out, and by the way, that's another thing, like you might want to, I don't know if you guys know, but I'm sure many of you guys out there do, but you have a couple of different ways of measuring objects with a caliper, right? So you can measure it just using the main prongs here, right? So I just measured out my circle, that's about, where is it, 29 millimeters here, right? Then in order to measure the depth of this element, the cone element that will be receiving my clamp, you can actually use the back end of the caliper here. As you can see, I'm sure that you've interacted with the caliper before. When the caliper expands, these little elements is what you can use to measure out depth, right? So you basically position the main edge of the caliper, or actually the trailing edge of the caliper here, and allow for that extension to go all the way into the part. And in this case, you know, gives me about 16 millimeters of depth here, when going or when trying to measure the cone. I could actually also measure the cone on this other part, but same idea, right? So jumping back here into Rhino real quick, I'll just give you guys a sense of those dimensions. I mean, it's already in here. I'm not going to spend too much time in the modeling part just because that's not the focus here. So 15 millimeters in radius, as I said, like it's like 30 millimeters in diameter, about a depth of 17. Also here in the lip, you know, 6 millimeters, very, very shallow lip here, right? So the initial dimension that I had was 1.7 millimeters. I was a little bit worried about this particular component because I thought, you know, let me delete this part, but I thought that it could be a little bit too flimsy, right? So that's why instead of just protruding it straight from here, I gave it a little bit, as you can see here on the right, I gave it a little bit more thickness or more beefiness just by coming from this corner and looking for the tangent point in the circle, right? That essentially increases my overall area, you know, kind of like supporting this element, and should allow for it not to, you know, so easily break. So this was my first prototype. I actually printed it here in yellow. Let me bring it into view. Oh, there's the camera actually. So I have, you know, the very first one actually printed out in a sketch using regular PLA. Now, why would you use at this point PLA, TOF, ABS, or in, you know, even the printer choice comes into discussion, right? Why would you use one or the other? So at this point, I was just trying to prototype quickly. I was just trying to find out and get a feeling for, well, will this work? Will this actually fit? How tight of, you know, the tolerances need to be against my, you know, my actual attachment point, and also just making sure that I'm measuring things properly. And as you can see here, in my very first attempt, so the circle is actually the same. I didn't change it. I just wanted to make sure that I was actually working with the, you know, right size, right dimensions, and that it would actually fit on my bike. But I made a mistake when positioning the upper lip of my part. I know that there's a little bit of a glare. I'll try to get rid of it in a second. But you can see how this is actually not spinning entirely. That's due to the fact that my cone here is not able to, you know, here we go. It's not able to get in or to penetrate all the way into my part. I've got actually like an extra millimeter, 2 millimeters maybe there. That's preventing me from actually matching the part over. That's due to the fact that I forgot to take into consideration the actual thickness of the material, right, that got rid of my extra millimeters. So that's one of the first things to consider when prototyping something quickly. You are likely to make mistakes, right? And that's a good thing. You're actually, you know, it's a good thing, especially because you have access to the 3D printer. Therefore, you're able to iterate quickly. So the goal here is not to have it right at the first go. The goal here is to be able to iterate, allow yourselves, you know, to make mistakes, learn from them, and then improve the design. So with that already, you know, mentioned, I had my second design here where I actually increased the diameter of the main circle. You know, as you can see here from V1 into V2, I actually started playing a little bit with the rounding some of the edges, filleting some of those out so that it wouldn't be so sharp. Getting better into the tolerances and making sure that the part would actually fit. And, you know, second test, actually the part starts to fit nicely. However, these parts were still being printed in PLA. And PLA, you know, it's a great material for prototyping, it's a great material for model making, but it doesn't really have, you know, great flexibility to it. It's actually a little bit brittle. And I was afraid that, especially, you know, during the winter time with cooler temperatures around, as I flex this part, oh, sorry, I was actually showing the Rhino file too, but as I flex the part could actually delaminate and explode and, you know, basically fail, and I would be losing my light. That's why I decided to then switch over to the final material that I wanted to prototype on, which is TOF. I decided to use TOF. You know, I of course had a handful of materials available, from carbon fiber, PLA, TOF, ABS, and the reason why I chose TOF for these particular applications is that, as you can see here, you know, I needed to create a part that was fairly robust, fairly strong. So, you know, carbon fiber, ABS would be good choices for that, but also had a little bit of a give, right? I wanted it to be flexible enough so that when I was actually ready to clamp it onto my bike, you know, here we go, getting it closer, I would be able to just flex it enough for it to go over my, you know, the width of my handlebar. Here we go. And in turn, clamp into the handlebar itself. Now, that extra give of the material would be fairly hard to achieve with an ABS part, even with a carbon part. Those materials really, you know, they are really strong, but they don't have a lot of flexibility, right? They don't really want to be pulled apart as much as other plastics. The reason being is just the stiffness is way higher in those materials. And that stiffness increases, of course, with a lower temperature, which doesn't really happen with tough. So that's why I decided to actually prototype in tough, right? As I said, I had, you know, PLA, tough, ABS, and carbon fiber to choose from. ABS or carbon fiber would be great for rigidity, would be great for strength, right? But they wouldn't have that little bit of a give that I needed just for the, you know, the assembly or the placement of my part the very first time that I was actually trying to clamp it over my handlebar. So that's why I decided to use tough. I switched over to the method. You know, you can use tough both in the sketch and in the method. That's no problem, but I had it loaded in the method, and the method does have, you know, a higher accuracy than the sketch. A little bit, not that much, but I wanted to keep it fairly straightforward. So finally, I printed a second to last part, realized that it was a little bit too small, and this is actually the model. Let me switch over to the 3D view. The final model of my part, right? I had already, you know, taken into consideration the cone that would be receiving my interfacing element, the actual perforation here for my securing screw, the extended section here for my handlebar. As I said before, the new handlebar didn't have or doesn't have circular profile, but rather, if you look at it from the top view, kind of like an ellipsoidal profile. What I did is just extending a little bit the circle so that it was a little bit thicker and wider to actually clamp on that on the new handlebar, and of course giving it a little bit more, way more thickness. As if you compare it here, you know, from the original, let me just make sure I'm sure, yeah, from the original to the final one, right? You can see how it's actually way beefier. So I wanted to make sure that that small, very small kind of fragile detail would be well supported by having enough material available to actually, you know, keep that extra how should I call it, extra element in place so that it wouldn't break so easily. And with that, I was ready to actually hit print. Now, printing these parts is very straightforward. I can jump here into, let me take you guys through Cloud Print. Here we go. So in Cloud Print, I've showed you guys before. I'll do it you know, really fast. I have both my printers available here. My method is actually printing right now, but even if it's printing, I can just go ahead and open the print environment at my file, which I had already you know, created and exported. And let me just, here we go, adding my light component, and that's it, right? It's already detecting that I have the tough material. It's already detecting that I have PVA. And in this case, you know, I'm sure that you guys might be wondering, well, when do you know? That's also a common question, right? How to know when to use supports versus no supports. And as you can see here, this part will actually require, if I, you know, allow the slicer to auto slice this part, it will generate supports inside of this conical section. I didn't want them though, just because of two reasons. First off, those would actually increase, I'll hit preview for you guys to see the supports being generated, but the supports would actually increase the print time, you know, naturally. It's just, you know, part of the process here. When you add supports, you're actually also adding a little bit more time for your printed part. And also, in the case of this particular part, I'll wait for this to finish slicing, but in the case for this particular part, since we're talking about a circular section, and it's also a fairly small bridging element section here, even if I didn't use supports, okay, here we go, right? So as you can see, the slicer is actually generating supports in here, just to make sure that this geometry is super clean and pristine. But the truth is that I really didn't need that, and I'll show you guys why, right? I really didn't need the supports so long that, and here's the disclaimer, right? So long that I'm good with having a little bit of a drooping, and I'm just switching into the macro lens here, but a little bit of a, here we go, yeah, a little bit of a bridge and an overhang happening there. So you can see here in the inside of my part how, trying to get it centered out, here we go, how that zipper line right here, right in the center of my part, is actually caused because of the lack of supports, right? So if I wanted a really clean part, if I really needed that to be 100% perfectly rounded, I would probably have to use supports. But with this particular application, the margins, were enough so that I didn't really have to use, oh, here we go. I didn't really have to use supports. I wasn't so worried about having such a clean set of overhangs. And that's the thing, right? If you don't have a massive span of open space that's unsupported by the part or in the part, you're probably okay in skipping the supports. That'll save you time, materials, but it all depends a lot on your part. And that's about it, right? That got me my final part. Let me get rid of the macro lens again. Got me my final part, final assembly. I'll show you how it looks like on the bike, but essentially I got my interfacing part for the handlebar, the attachment point, sliding my light in there, and finally the set screw. And that's about it, right? So fairly straightforward process. Fading again to cloud print here, just to show you guys the print time here with how it changes, the print time with supports. So we're talking about 4 hours, not too bad, but without supports, let me quit the print preview. I'll slice it without support so that you guys can see. So also no real need for a base layer in this case, because it's a very flat part. It didn't move around, so I didn't have to really use base layer. I'll slice it again for you guys to see. And while that slices, or that's being sliced, I'll just show you a video real quick of the part, the part in use, right? So this is actually how it ended up clamping up into my bike, as you can see, already out there. Sorry about the video being upside down, but I was filming it myself, so I had to sort of reverse the phone. And yeah, the part really worked well, has been working amazingly well. Yeah, so that's, oh, here we go, it's almost done. 3D. So yeah, it went from 4 hours to 1 hour, right? If I'm not using supports, I'm still getting a clean enough part. That's the way that I printed out this one in particular. So, all in all, an example on how to measure up a part, make adjustments to it, print between two different systems, sketch and method, and while selecting the appropriate material, in this case the tough material, and then finally getting my result out here with my actual prototype. So with that, I'm going to jump into the questions that we have today. I know that Alejandro has been collecting some of them. If you have any questions right now, you can definitely put them, I think it's to your right on the comment section there. And then here we go. Okay, so question 1. Can you print a full 3D, can you 3D print a full bike frame? No, you actually, well, okay. The answer is it depends, and those are kind of like the most annoying types of answers. You could potentially, there's printers that have that big of a build volume. You could print it out in metal. It's kind of tricky. I think that it's getting, the technology itself, 3D printing, it's getting to a point where you can actually consider printing such applications. I don't think it's ideal right now. I think we are at the point where the technology is better used for specific applications instead of trying to think about printing everything all at once, right? If that's true for many objects, even say for the caliper here. It's not made using a single manufacturing process. You have many manufacturing processes stacked on top of each other from machining to injection molding for the plastic parts and so on and so forth. So I think that a full frame, a full bike, that'd be tricky. Technically, it would be possible. I don't think it's recommendable at this point. What bike components can you print? How customizable can it get? Well, how customizable can it get? So you can print a lot of components. I've actually tested out a few, and if you like the content, do let us know, because I printed out anything from pedals, attachments for or mounts for the handlebar, some other elements just to store my spare tire, and the CO2 cartridges as well. So there's a lot of possibilities, I feel like, in printing out your own little supplies for the bike. And I can certainly bring some of those in future episodes if you guys are interested in seeing those. Can you print the handlebars or just the mounts? That's a good question. As I was saying here, so this particular handlebar is made out of carbon fiber, right? You can definitely, you could potentially print the handlebar as a shape. I don't think that you would be getting the same rigidity out of laid up carbon fiber as you would from printed carbon fiber, right? So when we're talking about carbon fiber that's been laid up, meaning you have the carbon fiber sheet and that's then covered with a resin, set aside to cure, it will not have the same properties as 3D printed carbon fiber. So physically, spatially, it will have similar dimensions, and I think it's a great way to actually test out the model, the sizes, the fit, but not so much the function, right? With 3D printing, I would, especially for these type of materials, I would not print anything that needs to bear a massive load, right? Kind of my limit so far is the pedals, and I can bring the pedals on the next episode. But yeah, the handlebar themselves, they bear so much weight that it'd be a tricky one to actually trust with such a massive amount of weight. What material is best for printing customizable bike components? The answer is it depends. As I said before, right? If you're just printing the component to see if it fits, anything from PLA to nylon would be probably fine. If you're printing it for something that needs to have a little bit of a give, as this particular mount does, tough is a great option because it has the same rigidity as ABS, but a little bit of a give. It's a little bit more elastic without being flexible, but a little bit more elastic than ABS. And say you had to print, or you wanted to print something that was load bearing, like the pedals. The pedals, I actually printed them out in both ABS and carbon fiber, and both of them work really well. So it all depends on the application. It all depends on the specific part that you're trying to print. And with that, it's always a pleasure to have you guys here. Let me know, if you like this type of content, if you want to see more of this how-to sort of step by step. If you wanted an extended version, I think that's also a possibility, right? Where we actually dive a little bit deeper into the printing process, into the design process. But yeah, wanted to try this one out. Hope you guys enjoyed it, and we'll see you next time. So again, as always, happy printing.